All right, for our last question here, it says consider the function f and the points a, b, and c. Complete the parts a through c below. So here's our function. Negative 16x times x minus 5 times x minus 7. And we have a equals 0, b equals 5, c equals 7. Find the area function, a of x, equal to the integral from a to x, f of t dt, using the fundamental theorem. Okay? And then we've got that. And then graph f and a. We've got some different graphs here. And then evaluate all this stuff and figure out what that means. We'll deal with that in a minute. It says evaluate a of b and a of c, and then interpret the results. We'll deal with that in time. And this is sort of a doozy, so here we go. What I'll first do is write down that area function again. So this is a function defined by an integral, and I believe that's a x. All right. So this says find the area function using the fundamental theorem. So that would be the integral from a to x, f of t. So that's going to be negative 16t times t minus 5 times t minus 7 dt. What we would need to do is to find the integral of this, or find the antiderivative of this. Your calculator is not going to be very much help here because you have a variable here and a variable here. And your calculator can solve when you have numbers, but cannot solve this algebraically when the algebra is here. So we're going to have to do the antiderivative process ourselves. Looking at antiderivatives, sometimes it's very much like a puzzle. You have to figure out which tool that you have to be able to solve the antiderivative. So does anybody know any tools that you have experienced to deal with antiderivatives? Something that looks like this.
Shouldn't we plug in a equals 0 on that integral there?
They do give us an a. We can do, yeah, and then that's a right there. Sure. We still don't have that sucker. Still don't have that x. Anybody have anything off the top of their head? Any strategies? Okay. U substitution is an option. The problem is, which I don't know how familiar you are with U substitution. Normally what you do is you set u equal to one of these terms, like you could say u is equal to t minus 5, and then you would have something like t is equal to u plus 5, and so you could have negative 16 times u plus 5, and instead of having t, you would have, or t minus 5, you would have u, and then instead of having t minus 7, you'd have some variation. Let's see, t was u plus 5, so you'd have like u plus 5 minus 7, and then d, you could replace du over dt equals 0. You could replace du with dt, but you are not super familiar with that. And plus, if you kind of look at this, you see that this new integrand looks very similar to this original right there. So all that to say, U substitution is out. Not really a very helpful option for us. As far as my way of thinking, since this is going to be in sort of a testing situation, is I would literally just FOIL this out and then multiply it by negative 16t. Okay? Or better yet, factor out that 16. Or pull it out using the constant multiple rule. And then, like I said, FOIL this thing out, and then use your power rule for antiderivatives. So t times t is t squared. t minus 7, so your negative 7t minus 5t, that's negative 12t, and then negative 5 times the negative 7 is a positive 35. So just flow that out, and then multiply that by this t. So we have negative 16, the integral from 0 to x of t cubed minus 12t squared plus 35t dt. So t cubed minus 12t squared plus 35t. And this, you should be pretty confident taking the antiderivative of, right? Miranda says yes. Thank you, Miranda. So Miranda,
Oh no.
antiderivative of t cubed.
You see, I was just nodding my head.
Well, that's fine. All right.
It's two.
Two to the fourth.
No, yes.
He's closer. Yes. It is t to the fourth
1 over 4
over
to
4.
over 4. Yeah, I kind of put the 4 over there.
Mm-hmm.
All right. Minus. Now I'll keep the 12 out there.
Minus 4 to
12.
Yeah, you're jumping ahead. I'm gonna use this. You are right, but I'm gonna just leave the 12 there so we're all tracking along. Remember the antiderivative? We power up and then divide it, and this is gonna be 35.
T squared
Over 2.
over 2.
Yep.
Over 2.
Over 2.
Over 2, and then this is evaluated from t equals 0 to t equals x. All right. Should we distribute that 16 or just leave it out there outside?
I think we should leave it out there
Let's
for now.
leave it.
Okay. Why complicate our life, right? So I'm going to substitute in x for t. So I have x to the 4th over 4. Y'all said that reduces to a negative 4. So negative 4 x cubed plus 35 halves x squared. So I'm substituting that x in for the t in each case. That negative 4 kind of looks messy, you can see that. And then minus, substituting 0 in for each one of those, I have 0 divided by 4, that's 0. Minus 0 cubed over 3, that's still 0. 0 squared times, that's still 0. So it's, I mean, if you wanted to, you could write 0 to the 4th over 4 minus 4, 0 cubed plus 35 over 2 times 0. And I'll write that all out just so you can remember how the fundamental theorem works, where you plug in the top number, subtract, plug in the bottom number, but this all goes away to 0. So I guess we've got the area function is equal to negative 16 times x to the 4th over 4 minus 4x cubed plus 35 over 2x squared. Okay. And so that would be our area function. I'll check and see if they like it all multiplied out or not. They do like it multiplied out, so grab a calculator. Let's go ahead and distribute that. Negative 16, so negative 4x squared. We need some help here. Maybe not. Negative 16 times a negative 4.
64.
Positive 64x cubed. And then negative 16 times 35 halves.
Negative 280.
Negative 280x squared. Let's consult the manual here. Negative 4x4, check. Plus 64x cubed, check. Minus 22 or 280x squared. We are correct in our answer there. Okay. Part B says graph F and A. Choose which of these is the following. Well, here's F, and negative 16x, x minus 5, x minus 7. And then there's A. What I would recommend is you just plug this into the calculator, plug that into the calculator, and see which one of those graphs it lines up with. For the sake of time, I'll just tell you the answer is B. Since y'all know how to plug stuff in. I'm more interested in discussing part C. Evaluate A of B and A of C. Interpret the results using the graphs of part B. Okay. So A of B means A of, let's say B was 5. And A of C means A of 7. What that would mean, if I go back to this description, that would mean the integral from 0 to 5 of f of t dt. And this one, A of 7, means I'm just plugging into 7. Kevin, this is a game you and I put, so it would be, so when you see a 7 right there, what does that mean you do when you say A of 7?
That means just the antiderivative.
No. Normally, if I've got A of x equals blah, 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 blah.
Okay. Oh.
And now I have A of 7 equals, there's a reason I'm asking you this.
Yikes.
A of 7. Let me back up. So, this is our function, A of x. Sort of like f of x, but it's got A instead of an f, okay? And when I say find A of 7, what is the process for finding A of 7?
Where there's 7, or an A, an X, or 7.
There you go. See, because I always ask you that question, right?
Yep.
With functions, okay? So,
Ask you. Yep.
all right. So, this would be from 0 to 7.
In this case, as we already have both numbers, we could plug it into the calculator.
Oh, yes, absolutely. You could. And if they ask for those actual numbers, then we're going to have to do that. And it says the value of A of 5 is blank, and the value of A of 7 is blank. And those are the only blanks that we need?
Yeah.
Then it says the value of A is the net area between f of x and the x-axis between x equals 0 and x equals 5. A of 7 is the net area between f of x. Oh, now hold on. Do they have an alternate definition here? They do. Okay, so hold on. So I take that back. So the first part is all three of these give us the opportunity of plugging in the number. Then we've got to figure out which one of these phrases is the correct interpretation. Okay, so to back up what Emily just said, just to make it very clear, she said, since we have the 0 and we have the 5, can't we just plug this into the calculator? And the answer is yes. You could go the integral from 0 to 5 and then plug in,
the original?
What's that?
Do we plug in the original, right?
Yeah, you plug in f of t. You plug in, yeah, it's just this guy right there, yeah, negative 16. Now you're gonna have to use x, but that's okay. The calculator's here. X minus 5 and x minus 7 dx. But your calculator can handle that. And this one over here would be, from 0 to 7 of negative 16x, x minus 5, x minus 7 dx.
Could we also just plug them into the original?
Yes, you could also just plug them into that. Since we found out that those are exactly the same. Your calculator will take less time evaluating this than it'll evaluate this. This might take quite a few seconds. This one will be able to be instantaneous. Okay, so we've got the first half, but then we need to examine which one of those three answers is correct. And I hate looking at words and trying to figure out if it's right. I would rather just play the game. What does this mean? Can we know that from our knowledge? What does the integral from 0 to 7 of f of t dt mean? Ms. Weaver? What does that mean?
Integral of
the antiderivative.
Yes.
So the antiderivative from 0 to 7.
Okay, that's correct. The antiderivative is, or the integral is the antiderivative, but the antiderivative, it tells you also something meaningful, like an actual physical quantity.
The area under the curve.
Mm-hmm. That is the area under, now which curve?
The curve of the yeah, f of t.
Integrand. Mm-hmm. It's the area under f of t. We would also say, and above, well, it doesn't necessarily have to be above if it, because if it goes below, then it's negative. And so I don't even know if I should say the area under f of t. I should say maybe the area between f of t and the x-axis. Because if it's positive, it's going to be positive. If it's in negative territory, it'll be negative. And it is also bound by t equals 0 and t equals 7. So the idea is if our graph looked like this, then the area would be that, and that would give us the value of the integral. If our function was something like that. So, looking at option A, it says the value of a of 5 is the net area between f of x and the x-axis, between x equals 0 and x equals 5. Sounds pretty good. A of 7 is the net area between f of x and the x-axis, between x equals 0 and x equals 7. That's almost exactly what we just said. So, option A is looking pretty darn good, but maybe B is better. It says the value of a of 5 is the area under f of 5, and a of 7 is the area under f of 7?
No.
No. Maybe even if they had said f of t, the area under f of t, we would allow it. But the area under f of 5 is literally going to be an infinitely thin line. Okay? Because if this is your function, and there's 5, and there's f of 5, the area under f of 5 is like, that's it. So, not B. Option C says the value of a of 5 is the area between f of x and a of x, between x equals 0 and x equals 5, and a of 7 is the area between f of x and a of x. Between x equals 0. That is not correct. It's not the area between the function and its antiderivative. It's between the function and the x-axis. All right. And those numbers, in case you are curious, are negative 1,500 and negative 1,372. Okay. So, just to summarize this particular problem, we just FOILed it out and then used the antiderivative power rule. We use the calculator to graph it, and then we also use the calculator to find the antiderivatives. And we know now for sure what that definite integral means. Rest of this time I can go back to any one of these questions and answer any follow-up questions that y'all may have. Yes. Does anybody have any follow-up questions?
You did a good job, thank you.
All right, I'll also be walking around to see if you have questions on a particular homework problem.
Yes.
Thanks for watching. Like and subscribe.